Hello and welcome to my Module 4 Excel report for Ms. Benzie's quantitative literacy class. I have my screen already pulled up here on my Excel spreadsheet. I have my formulas already showing, so I can just scroll through that right fast to show you my formulas that I use for all my problems. Here we go. And I think this is the last one. Yes, it is. Okay, let me get back to the top and take this off of there. Okay, number one was a worldwide poll that was surveying people about whether they wanted to stay in the country they currently lived in or whether they wanted to move. And we were asked to make a table and a pie chart and a bar chart, because those who said they wanted to move gave their top three choices, and we were to see how that looked. I found that those who wanted to stay in their current country, that was 29%, and those who wanted to move was 71%. Out of that 71%, some of the people surveyed said that they would like to move to a specific country. I found that 34% wanted to move to the United States, and 10% wanted to move to Canada, and 10% to the UK. I came up with these numbers by dividing 24 by 71 and so on and so forth for each of the different countries. Now, I only divided by 71 and not 100 because only 71% out of the 100 said that they would like to move somewhere else. So there's all of my work for problem number one. And on number two, we were asked to make a situation to go with a function, to go with this function of and I done a taxi cab ride. The cost of the taxi cab ride for dollars per miles. And I made a bar graph and a scatter plot to show. The cost to take a taxi cab ride was not bad at all. The initial price was $2 to start, and then from there it increased by 75 cents per each additional mile driven. At no point did the graph cross the x-axis, because you cannot measure distance in negative values. There was a steady rate of increase on the graph. However, the more miles you travel, seemed like the less it cost. For instance, for 4 miles it cost $5, and 13 miles it cost $11.50. Since the initial cost of the ride in a taxi cab is $2, that is where the graph crossed the axis representing the cost, the y-axis. Okay, let's move on to number three, which is a problem we had some experience with from Module 1. This was the sales of a sneaker company, discount sneaker company. We wanted to find where they their initial investment was, their lowest point for profit, and then, you know, when they broke even, and their highest. And I labeled these accordingly on my graph. The total initial investment was $240, so they started out with the negative $240. And they didn't seem to lose too much, because at the absolute lowest point, they were only down to negative $304, which is about 64 less than their original investment of 240. After hitting rock bottom, which was right there with that thunderbolt, the company began to break even after selling about 13 pairs of sneakers, which is right here. And then once they sold around 19 sneakers, they had made a profit of over $500 up here where the sun is shining. Okay, and for number 4, we were to find the height in feet for, say, if a pitcher threw a ball in the air, straight in the air, we wanted to find the highest point that it traveled, and we wanted to find when it hit the ground. I created a table and a graph to find the height in feet and the time in seconds. If a pitcher threw a ball straight into the air, we needed to find the maximum height that the ball traveled and the point that it hit the ground. The maximum height the ball reached was 275 feet, and that took 4 seconds for that ball to reach that height. The ball hit the ground somewhere between 8.24 and 8.245 seconds mark. I was able to calculate all of this using the function h of t equals negative 16 t squared plus 131 t plus 7. And as usual, Excel made this problem very easy to figure out. Cannot say enough about Excel. Okay, and for number 5, we were to, this is the crazy mathematician guy who opened a resort in Costa Rica. We were to find the best option that would cost the least to stay, and the one where we could stay the longest. At this resort in Costa Rica, the option that would allow you to stay for the least amount of money would be option 1. You could stay for 8 days, and the cost would be $900. The option that would allow you to stay for the longest would be option 3, and this option would allow you to stay for 17 days for $1,000. Option 2 would be the least sensible option of them all, because you could only stay for 4 days and the price would be $1,000. And we just made a table and we made graphs for each one of those. And the final one is the carbon dating of fossilized remains found in England. We wanted to find out how old those remains were. I made a graph and table, and we put our function in. Basically, according to my findings, the age of the remains are 461.61 centuries old. I believe that's how I should say it. This number was as close to 0.37% as I could get. I took a long time magnifying these numbers in Excel and trying to get right exactly on that 0.37 mark as I could. Looking at the graph, we could see that there was a steady decline over the years in the presence of the carbon, -14. From here, there's a steady decline until it gets to around about here. Then it kind of evens off and just stays around the same amount from there on out. And I believe that is the conclusion of my Excel report. Thank you very much and have a good day.